Good morning to you all. As I sit here ready to do this lesson, all I can do is hear the birds chirping. Makes me hopeful that spring will be coming and we'll be able to get back together again. This morning we are going to learn how to add and subtract rational expressions that have unlike denominators. So on Friday, you did some practice of finding least common multiples to which we need to have. So let's look at our first example. All right, here's my first example. I want to subtract 3 over 4x minus 1/7. So in order to do that, I need to put each fraction over a common denominator. If you look at my denominators here, they don't share any factors. Another way to say that is that they're relatively prime to one another. So what does that mean? So when they don't share any common factors, their least common denominator, their least common multiple is just the product of the two. So my least common denominator is going to be here, 28x. Now, before I can subtract each one of these fractions, I have to put them over 28x. So let's think about how we do that. All right, what do I have to multiply 4x by to get 28x? I have to multiply it by 7. So that means I have to multiply the numerator by 7. So I get 21 over 28x. If I have 1/7, what do I have to multiply it by to get it over 28x? Well, I have to multiply by a 4 and an x. So in the numerator, I get 4x. So now I can just subtract 21 over 28x minus 4x over 28x. Now I can't combine 21 minus 4x because they're unlike expressions. So I'm just going to write my answer like this. All right, back in the beginning, what are my restrictions? X cannot equal 0. So down here I have x cannot equal 0. So here I just took a little extra time to show you how to find the common denominator. Then I have them over a common denominator. Then I subtract the numerators, put them over the common denominator. All right, let's look at another example. All right, so we need to find the least common denominator of x minus 4 and x minus 3. Again, those are relatively prime to each other. They're two different factors, so their least common denominator is just going to be the product of those. We are going to leave our common denominators in factored form, so you do not need to multiply that out. Denominators you will not need to multiply out, but numerators you will. Back up here, we see x cannot be 4 or x cannot be 3. All right, so now I need to put each one of these fractions over the common denominator. So what am I going to multiply 7 by and x minus 4 by to get this common denominator? I'm going to multiply by x minus 3. So on the top, I'm going to get 7x minus 21. If I take 2x over x minus 3, what do I need to multiply by to get x minus 3, x minus 4? I need to multiply by x minus 4 x minus 4. If I multiply the numerators, I get 2x squared minus 8x. So now if I go ahead and add these, like I said, we can leave the denominator factored. We get 2x squared minus, because I have 7x and a minus 8x, so I get a minus 1x minus 21. Now when I get to this step, I do want to check and see if I can factor this out and cancel anything out here. So let's see, factors of negative 42 that add up to negative 1 would be 6 and 7. So as a matter of fact, this is going to factor. So we're going to need to factor that just in case we have something that cancels out. So I'm going to go back up here so you can see how I would factor this. So this comes out to be negative 42. So if I do negative 7 times 6, I get, and add them, I get negative 1. So I have to rewrite this as negative 7x plus 6x minus 21. Here I can only pull out a common factor of an x. Here I can pull out a common factor of a 3. Sorry, that's Jinx. So my final answer here will factor into x plus 3, 2x minus 7. So there's nothing here that I can cancel out. X cannot be 3, x cannot be 4. All right, let's look at another example where the denominators are not necessarily relatively prime. All right, my example is 5x minus 1 All right, so I need to find that least common denominator. So what I am going to do is I'm going to factor each of these denominators. So this factors into x minus 2, x minus 1. This factors into 2 times x minus 2. So my least common denominator has to have every factor that I see here. So it needs a 2, it needs an x minus 1, it needs an x minus 2. And the highest power, each of these only have power of 1. So that would be my least common denominator. All right, so now I have to put each of my fractions over the least common denominator. Remember, we're leaving our denominators in factored form. We're multiplying out the numerators. All right, so what do I need to multiply this by to get this common denominator? I just need to multiply by 2. So I get 10x minus 2. All right, my second fraction here. What do I need to multiply by to get this common denominator? I need to multiply by x minus 1. All right, on the top here, in order to simplify this, I am going to need to FOIL. All right, so my first are negative 2x times x, so I get negative 2x squared. My outers are a plus 2x. My inners are a minus x, and my lasts are a plus 1. So now I'm going to go back to my problem, and I need to subtract these because my original problem was subtraction. I'm going to combine the plus 2x and the minus x to get x. All right, so my final answer here, I'm going to go ahead, change subtraction addition, change all these signs in the numerator. So I'm going to get 2x squared plus 9x minus 3. The good news here is that factors of -6 that add up to 9, there isn't any. So that's my final answer. There's no more factoring. I just should say x cannot be 1, x cannot be 2. From up here, x cannot be 1, x cannot be 2, x cannot be 2. All right, I'm going to do one more example for you, and I'm going to let you try one. All right, this we don't need to factor, but this we can factor into x times x plus 1. So my least common denominator is going to be 12. Has to have a factor of an x, has to have x plus 1. The largest power of the x here is squared. So I need to have 12x squared times x plus 1 as my common denominator. So for this first fraction, I just need to multiply by x plus 1. So I get 8x plus 8. Now for this one, again, leave the denominator factored. I already have an x plus 1. I already have 1x. So I definitely need to multiply by 12, and I also need to multiply by another x so I can get the 12x squared. All right, up here, I'm going to multiply by 12x, so I get 12x squared. Now I'm going to add those together. So I get 12x squared plus 8x plus 8, if I write that in standard form with descending powers of x. All right, if I look at that, you can see that I can factor a 4 out of here. And I do want to do that because then I can simplify that 4 with the 12. So this problem does take some simplification to complete. Before I erase the top so that you can see, we can see here that we have x cannot be equal to 0, x cannot be equal to -1. Okay. All right, so if I take my fraction here and factor out 4, I am going to get 3x squared plus 2x plus 2 over 12x squared, x plus 1. All right, factors of 6 that add up to 2, there isn't any, so we're not factoring there, but I can simplify here. 4 goes into 4 once, 4 goes into 12 3 times. So that will be my final answer. 3x squared plus 2x plus 2 over 3x squared, x plus 1, x cannot equal 0 or negative 1. All right, I'm going to put a problem up and I'm going to ask you to pause the video. I want you to try to do it, and then I am going to show you the solution. All right, so everybody, I want you to try this one. All right, go ahead and pause and come back when you have a solution. All right, so I'm going to factor here. Okay. So my least common denominator is going to be 12. X plus 3, x minus 4. What do I want to multiply that by to get this? I need to multiply by 12. So I get 12x here. For this one, I need to multiply by x plus 3. So I get 5x plus 15. All right, so if I add these two together, I get 17x plus 15 over 12 times x plus 3, x minus 4. And from the beginning, I have x cannot equal 4, x cannot equal minus 3. All right, I hope that gives you some help. Check your Google Classroom for some homework problems. Thank you.